There's no instrument on Earth built to measure what happened on the other side of the galaxy in December of 2004. So scientists had to invent a number that doesn't exist anywhere else in nature: a magnitude 32 earthquake. For comparison, the worst earthquake ever recorded on this planet was a magnitude 9.5. The number you just heard isn't 10 times worse. It isn't 100 times worse. It's somewhere in the range of 32 sextillion times stronger than the most violent thing the ground beneath you has ever done. And that earthquake didn't happen on Earth. It happened on the surface of a dead star, 50,000 light-years away. A star that's been extinct, in the way you'd normally use that word, for longer than humans have had language. When a massive star runs out of fuel, it doesn't fade out. It collapses, violently, in under a second. The outer layers blast outward as a supernova. What's left behind is the core, crushed down into something almost incomprehensible: a neutron star, about 20 kilometers across, a city end to end, and yet it weighs more than your entire sun. 1 teaspoon of it would weigh roughly 1 billion tons. Some of them spin hundreds of times a second, faster than anything solid has any right to spin. But every so often, something goes wrong during the collapse. The magnetic field doesn't settle. It winds tighter. It compresses. It feeds on itself until it becomes something physics can barely tolerate. That's a magnetar, a magnetic field 1 trillion times stronger than anything Earth produces. Strong enough that the empty space around it starts to misbehave. Particle pairs flicker into existence out of nothing. The object responsible is called SGR 180620. Its outer shell is a crystalline lattice, roughly 10 billion times stronger than steel. But even a crust that strong has a limit. Deep inside the star, the magnetic field doesn't sit still. It twists, drags, reorganizes, and all that motion puts enormous stress on the rigid shell sitting on top of it. Eventually, the crust can't hold. It cracks. The crack itself moved only a few miles along the surface, a flinch by stellar standards. But in the first 200 milliseconds of the event, the star released as much energy as the sun produces in 250,000 years. That energy crossed 50,000 light-years and arrived at Earth as a wall of gamma radiation. It carried roughly 10 trillion times the sun's entire energy output over that same fraction of a second. Every gamma-ray detector pointed at the sky that day, saturated instantly. Equipment built specifically to survive extreme cosmic violence simply couldn't process what hit it. And your planet's own atmosphere responded. The upper layers of air above your head, measurably ionized, recorded by instruments around the world, for an event that started on the far side of the Milky Way. Magnetars don't announce themselves before they erupt. They sit quietly, bleeding magnetic energy into the dark for thousands of years, completely invisible until the moment they're not. We've confirmed around 30 of them in the entire galaxy. Scientists estimate there are over 1 million more out there that we simply haven't caught in the act yet. The only reliable way to find one is to wait for it to detonate. In 2020, one did exactly that from inside our own galaxy. A burst we'd previously only ever traced to other galaxies entirely. It came from a magnetar called SGR 1935 plus 2154, sitting quietly in the Milky Way the whole time, unnoticed, until it wasn't. The nearest confirmed magnetar we know about sits roughly 9,000 light-years away. That number is the only thing standing between the world you live in and the one SGR 180620 briefly touched in 2004. And that number isn't fixed. Neutron stars get launched across the galaxy at hundreds of kilometers per second by the very explosions that create them. There's no early warning system for this, no defense waiting in reserve, no alarm that sounds before the destruction does. Because the warning and the destruction are made of the exact same light, arriving at the exact same moment. A Magnetar isn't hunting anyone. It isn't aiming. It doesn't know you exist, and it never will. That's what makes it worse, not better. Physics doesn't negotiate. A magnetic field doesn't care what it's pointed at. A crust doesn't crack with any intention behind it. It just cracks, because the stress finally won. Somewhere out there tonight, one of these dead stars is sitting in the dark, decaying, building toward a crack none of us will see coming. We don't know which one. We just know that the last time it happened, the sky over your head answered back, and you never felt.